Okay, we're going to be looking at Unit 1 review, and I kind of already started here, but I'm not going to restart it. But you want to make sure that you're going through this with me. I'm going to be working the odds, so you can work the evens, check your work on, or check your answers on the back. But you might also think about hitting pause before I begin the problem, and then you trying it on your own and seeing if it matches kind of what I'm doing. Okay, so the first thing this question says is label each number with its most precise name, then place the numbers in order from smallest to largest on the number line. So I'm just going to place them and then I'll name them. Okay, so I started with -2 here. It's pretty easy. You can sort of see that. And then the next thing you're seeing is negative square root of 4.9. And it is perfectly fine if you can't do that in your head, okay? You have a tool, you've got the calculator, go ahead and utilize your tool. So we're going to go to the calculator and we're going to type, let me see if I can darken that up just a little bit. I think that's as dark as I can get it. And we're going to type square root of 4.9 and hit enter. And you can kind of see here, that's going to give us 2.21. Okay, so this guy right here is actually negative 2.21, which, you know, is -1, -2. Negative 2.21 is just beyond. Maybe I could change colors to differentiate here. Right here. Okay, so that right there is the negative square root of 4.9. Just got it from the calculator. Okay. Next number here is 0. Nice and easy. So we're going to stick 0 right here in the middle. And then negative pi. Remember, pi is 3.14. So if I want to place pi on the number line, then it's going to be, I'm going to go back to red here, 3.14. Oh, but it's negative, so I need to go negative 3.14. So right here we're going to have negative pi. And then we have the square root of 0.49, the square root of 0.49. Again, you know, you have the calculator. Utilize the tool if you're not sure what the square root actually is. It is kind of hard to read here. 0.7, basically impossible to read here. But it was 0.07, excuse me, 0.7, which is going to be 7/10. So actually I could make my tenths marks here. I could absolutely go through here and 1, 2, 3, 4, 5, 6, 7, 8, running out of room, 9. Okay, so I could make my tenths marks, and I would go to the 7th mark and put a point, and that would be my square root of 0.49. And then I have another point at 1, so I'll just throw that guy on there, and his at 1. Okay, so you can see the order here would be negative pi, negative square root of 4.9, -2, 0, square root of 0.49, and 1. Okay. If I'm going to name them by their most precise name, -2 is negative whole number, so it's an integer. The negative square root of 4.9, when I put it in the calculator, was a never-ending non-repeating decimal, so it was irrational. So this guy right here, he was irrational. 0, remember that's the only one that identifies as a whole number. Negative pi is also irrational. Remember, pi is always irrational. But the square root of 0.49, when we put it in the calculator, it ended. It was a decimal, but it ended, so we call that rational. And then 1 is a natural number. Remember, positive whole numbers are natural numbers. Okay. All right, moving on to the bottom section, not the bottom section, but 3 through 17. These are just number properties, just kind of simple number properties. You will have a calculator tomorrow, so you will be able to use it as a tool. But remember, if a problem asks you to show work, that means that work is part of the of the process of getting points. Okay, so if it says show work, you need to make sure you're actually showing the work. Okay, so the first thing I'm going to do is try to figure out what's a common denominator between 5 and 15. Right, so 5's first multiple is 10, next multiple is 15, and then that means 15 doesn't need to change because I can change 5 to look like 15, right? So I'm not sure what's going on with the crazy lighting situation. I don't know why that's so hard for you to read. Anyways, okay, so what I'm going to do here is I'm going to multiply the first fraction by 3 over 3 so that I can get a common denominator of 15. So that would be 3 over 3 times, and I'm changing 3/5. So that becomes 9 across the top and 15 across the bottom. And then I'm just going to combine, right? So I just made 3/5 look like 9/5. I just made 3/5 look like 9/15. So we have 9/15 added to 6/15, right? And 9 plus 6 is actually 15. And 15 divided by 15 is actually 1. So this 3/5 plus 6/15 is actually 1 when we add them. Okay. Number 5, we have a multiplication of two fractions. So remember, when we're multiplying fractions, we go straight across. So we're going to do -2 times 14, -2 times 14, which is -28, and 7 times 3, which is 21. And then we just want to make sure that this does not simplify. But 28 and 21 share a common factor, and the factor they have in common is 7, right? So if I want to reduce this fraction, then I can divide the top and bottom by 7. 28 divided by 7, that's -4. 21 divided by 7, that's 3. If you're kind of stuck on one of these and you can't figure out how to reduce it, you can just type 28 divided by 21 in the calculator, and the New Magical Inspires will reduce it for you. All right, number 7. We have a little order of operations issue here, right? So parentheses first, I actually want to add -1/3 and 5 first, but I need to make sure they have a common denominator. So I'm just going to take 5 over 1, and I'm going to multiply 5 over 1 by 3 over 3 to get 15/3. So this guy is going to become 15/3. So I'm going to go fix my lighting. Hang on. Maybe this lighting situation will be better. Okay. So I'm replacing 5 with 15/3. This is going to become 2/5 times 1/3 plus 15/3. That's much better, much better. Too much fake lighting. All right, so now that I have a common denominator, I can add inside. So I have 2/5, and I'm going to add 1 plus 16. Denominator doesn't change. Remember, when you're adding fractions, denominator doesn't change. And then I'm going to multiply straight across, right? Just multiplying two fractions. So 2 times 16 is 32. 5 times 3 is 15. So this is 32 over 15. And if I wanted to write that to a mixed number, I absolutely could. I would say, how many times does 15 go into 32? And you would say 2 times with 2 left over, right? Because that would be 15 times 2 is 30. So that would be 2/15 left over. So if I wanted to do something else with this number, like put it on a number line, I would then make it a mixed number so I would understand how much it was worth. All right, moving on to question 9. When I multiply two radicals together, just like when I multiply two fractions together, the stuff inside changes, okay? So square root of 3 times square root of 3 is the same thing as the square root of 3 times 3, which is 9. And the square root of 9 is just 3. Number 10, excuse me, I'm moving. Well, let me just do number 10. The only difference between these two is square root of 3 times square root of 3 and square root of 3 plus square root of 3. Okay, so you need to think about the fact that if I multiply x times x, I get x squared, right? So technically I could have written this as the square root of 3 squared, which would have given me the square root of 9, which is 3. But when I add x plus x, I end up with 2x. So if I add square root of 3 plus square root of 3, I just end up with 2 of those square root of 3s. So we just want to combine them like they're like terms. Number 11, I'm multiplying two radicals together. And so I multiply outside times outside, and then I multiply inside times inside. So outside times inside, 2 times 5, we get 10. Inside times inside, square root of 6. So unlike the addition where I didn't change the radical, with multiplication, the radical will change. And then I would ask myself, does the square root of 6 simplify? And the answer is no, because it's only 2 times 3, and I can't take the square root of 2 or 3. So my final answer is 10 square roots of 6. Okay. Moving on to number 13. I do want to make sure as I'm working these problems that I'm making sure that if it has a radical in it that does simplify, that I go ahead and simplify that, right? Because I might just multiply 4 times 6 here and end up with 24 square root of 4. But that actually simplifies further. So it's right. It's just not as right as it could be. So I would say, okay, but I know what the square root of 4 is, right? If I take the square root of 4, I end up with 2. And then 24 times 2 is 48. So make sure if there's a radical in the middle of the problem, you go ahead and you simplify that. All right, number 15. I'm going to draw a little line here because that's a little hard to deal with. I'm adding all these square roots of 7, but I'm adding and subtracting, which means my radicand, or my radical, however you want to think about that, doesn't change. I'm going to have square roots of 7 at the end of the problem if all I'm doing is adding and subtracting. Then I'm going to add 4 plus 7 minus 15. 4 plus 7 minus 15. 4 plus 7 minus 15. Okay, so just add up all the coefficients. So 4 plus 7 is 11 minus 15. And 11 minus 15 is negative 4 square roots of 7. Okay, so just right into the coefficients. 4 plus 7 is 11. 11 minus 15 is negative 4. This guy right here, we didn't ever actually get to cover him, but you could just stick him in your calculator and you would end up with 7/8. Right? So what we are going to end up learning, hopefully soon, is that when we take something to the 1/2 power, that's really the same thing as taking the square root. Number 17, pretty simple order of operations problem. First, you add the numbers inside the parentheses, right? We're talking PEMDAS here. So we have negative 3 times 6 minus 7, which is negative 1. And then we have negative 3 times negative 1, which is 3. And then 3 plus 8, which is 11. So pretty simple, pretty simple. Just make sure you got parentheses, exponents, multiplication, division, addition, subtraction. PEMDAS. All right, moving on to question 19. So in this section, we're finding perimeter and area. Remember that perimeter is just the sum of all the sides. So if there are 4 sides, I should be adding 4 numbers, okay? So 4 sides, add 4 numbers. So 5/3 plus 5/3 plus 5/3 plus 5/3. Or because these are all the same, because it's a square, I could just say 4 times 5/3. 5, 10, 15, 20 thirds. So my perimeter is 20 centimeters. You can go ahead and reduce that to a mixed number if you want, or you can just leave it 20 thirds. I'm perfectly happy with that as well. Okay, my area for a square rectangle shape is length times width. So in this case, length and width are actually the same number, but we have 5/3 centimeters times 5/3 centimeters. And I'm putting I'm putting the units here because I want you to understand that units-wise, when we multiply units as well. So 5 times 5 is 25, 3 times 3 is 9, and centimeters times centimeters is centimeters squared. So my area will always have square units, not just when it's a square, but all the time. Okay, 21, when we look at the triangle here, perimeter is still add up all the sides. This time we have 3 sides to the triangle, so we add 3 numbers. So we would say we're going to add 15 halves, we're going to add 15 halves, we're going to add 14 thirds, right? And I'm going to go ahead and start with the 2 that have a common denominator. So that's going to be 30 halves plus 14 thirds. But 30 halves actually reduces to 15. And now I need a common denominator, right, so that I can add these. So I'm going to multiply top and bottom times 3, and this is going to become 45 thirds plus 14 thirds, which would be 45 plus 14, 57 thirds inches, right? So a perimeter, we just keep those units the same because we're just adding up a bunch of inches and we're getting more inches. All right, formula for the area of a triangle is 1/2 base times height, or base times height divided by 2. You can do it either way. I'm going to stick with the 1/2 since I've got fractions here. That's going to make my life a little easier. So my base would be 14 thirds. Maybe I should put my 1/2. 1/2. My base would be 14 thirds. My height would be 20 thirds. So across the top of the fraction, I'm going to multiply 1 times 14 times 20, which is going to give me 280. And then 2 times 3 is 6. 6 times 3 is 18. And I'm going to be able to simplify this at least by 2. So if I divide both by 2, that would be 140 over 9. And this is 2 times 7 times 10, and this is 3 times 3. So that's as far down as it goes. So this would be 149 square inches. 149th square inches. Okay. Number 23, which is our determine the area of the shaded region problem. This is like a donut, right? So if I cook a donut, I make the donut, I cut out the hole. But I got to start with all of it before I remove the inside. So what we're going to do here is we're going to do outside figure minus inside figure. So we'll find the area of the outside, we'll find the area of the inside, and then we'll subtract them. So if I start with the area of the outside, right, that's an 8 by something foot rectangle. So I need to figure this out. Well, this is 2 feet. And this is 1 feet, and this is 2.5 feet according to the measurement on the inside. Okay, so that means this whole thing is 2, and then 4.5, and then 5.5, so 5.5 feet. Okay, so in order to find the area of the outside, I'm going to multiply 8 times 5.5. So 8 times 5 is 40. 8 times 1/2 is a 4, so that would be 44 square feet. I hope I did that right. It'll be embarrassing if I didn't. And then the inside of the rectangle is 4 by 2.5. So same formula, same base times height, area formula. So we say the area of the inside is 4 times 2.5. So 4 times 2 is 8. 4 times 1/2 is 2. Combine them and you get 10 square feet. And then in order to find the area of shaded region only, right, just like the donut, we take out the middle part. I'm sure you've done this before. The area of the outside minus the area of the inside. This is going to give me area of the shaded is 44 minus 10, or 34 square feet. Oh, hi, you couldn't see any of that. Area of the shaded is outside minus inside, so we do 44 minus 10, and we get 34 square feet. This is a question that ACT loves to ask. Okay, looking at 25 and 27. Actually, let's do 26 and 27 so we can do one of each here. Remember I said, like, you absolutely can do this by hand, but it's almost absurd to do it by hand. So the way this works, I'm going to use my simple calculator here so you can kind of see. You can put it all in your big calculator, but I'm going to actually just multiply 7.8 times 2.9. Well, I'll do it with a calculator. You guys will have them do it that way. So we're going to multiply 7.8 times 10 to the 4th. And we're going to multiply that. I might get out of the exponent. Times 2.9 times 10 to the negative 8th. Okay, so you're going to get this number right here, 0.002262. 0.002262. Right, but we want the answer in scientific notation, correct scientific notation. So we're going to take this decimal and move it 1, 2, 3 places to the right. So this is now 2.262 times 10 to the, what did I move it? 1, 2, 3 places to the right. So it's going to be negative 3. Remember, if it started as a tiny number less than 1, the exponent's going to be negative. And then, of course, some computations will have you cut this off to 2.26 times 10 to the negative 3rd. If this number were 5 or bigger, 26 would have rounded to 27. Okay? And 27. I can use my calculator, my simple calculator, right? If I'm using this calculator, I'm going to hit Control Divide to make the big fraction. We have 7.8 times 10 to the 4th. And in the bottom, we have 2.9 times 10 to the negative 8th. And that's going to give me this number. Notice the E12 over here because that's your scientific notation, okay? They're telling you from the calculator standpoint, because it's not going to cut off decimals like we do. It's telling me that scientific notation would be 2.68966 e to the 12th. But for us, we don't do e to the 12th. We do times 10 to the 12th, right? And then, on top of that, we don't use all these decimals. We really only want 2 decimal places after, 2 numbers after the decimal place. So 9 is going to round 68 up, and it's going to become 69 times 10 to the 12th. So that would be my final answer. Okay? All right. Almost there. Just a couple of more here. The graphings are pretty easy. We're just looking at coordinates, okay? So 29b would be 5 to the left, so that would be negative 5. I always go left and right first. And up 5, that's positive. So that's positive, right? 31d, you go 2 to the left, so that's negative 2. You go 2 down, so that's positive 2. That's also negative 2 because down is negative 2. Sorry. And 33D shouldn't be D. Let's do 33. What's not on here? F maybe? Yeah, F isn't on here. So let's do F. So that would be 2 to the right, which is positive, and down 6, which is negative. All right, find the midpoint. Maybe you want a midpoint formula, right? So a midpoint formula is add the x's together, divide by 2, add the y's together, divide by 2. Remember, this is from your first coordinate, this is from your second coordinate, okay? So we could call this x1 and this x2. We would call this y1 and this y2. So we're going to take the average of the x's, negative 3 plus 9 divided by 2. Take the average of the y's, negative 3 plus negative 3 divided by 2. 9 minus 3 is 6. 6 divided by 2 is 3. Negative 6 divided by 2 is negative 3. So this right here is my midpoint. And it says to graph. I'm not going to take the time to graph for you, but I absolutely could come up here and or even draw my own. Okay, I'm going to do one for you. So if I want to plot negative 3, 3, that's 1, 2, 3, 1, 2, 3. Right here is F, and G is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 3. Right? So here is, if I want to think about this as a line segment, here's my line segment. And then I want to make sure 1, 2, 3, 1, 2, 3 actually appears to be in the middle of that. Okay, so I feel like I did a pretty good job here. That was F. Negative 3 was E. I'm having issues today. Okay, one more. One more and then we're going to call it quits. So, average my x's, 2 plus 5 over 2. Average my y's, 5 plus 2 over 2. This is 7 divided by 2, which is 3.5. This is 7 divided by 2, which is 3.5. And if I want to make a quick sketch to make sure I did it right, first point L is 1, 2, 1, 2, 3, 4, 5. Here's L. Second point is 1, 2, 3, 4, 5, 1, 2. Here's my M. Right, so here's my line segment if I want to think about a line segment that way. And then, I guess it doesn't say make a line segment, but if I wanted to think about the line segment that way, I could. And then the point 1, 2, 3, and halfway more. 1, 2, 3, and halfway more seems to fall in the middle of my line segment. Okay, guys, I hope that was really helpful, and I hope that you do super well tomorrow on the quiz, and I'm excited to see you guys be brilliant. Have a good night.